Friends, we are in our lecture on probabilistic security risk assessment, and this is second lecture of design basis threat. We saw there are two major elements in PSRA, that is probabilistic security risk assessment. One is threat, other one is vulnerability, and of course after completing the analysis we evaluate the consequences also. But then design basis threat is an element which keeps getting focused at all stages of the security risk assessment. Now, what we will be discussing is definition of design basis threat and requirement of DBT. So, design basis threat, and we will call out DBT. Formulation of design basis threats, how we arrive at the characterization of design basis threat, and why even in the present context other sequences along with the design based threats are required to make the analysis more holistic, but here we will focus on DBT only. And major design options requirements, okay, and then simulation or simulator, role of simulator, but that does not form our topic. Then human factor considerations in design basis, and yeah, so all this is governed by various domains in various publications in open domain, and of course from international agencies like IAEA and all. Now, what is threat? Threat assessment is the practice of determining or domain of determining the credibility and seriousness of a potential threat, as well as probability that the threat will become a reality in the context of what are the defense provisions that are available. Okay. So, while doing this analysis, there will be a list of threats, many things will go out of the list, many things will become combined, and they will form a design basis threat, and then the objective is to demonstrate the safety of the plant or security of the plant, or to demonstrate the effectiveness of security provision in the plant against these threats, so that no consequences will be there, or even if there are consequences, they are manageable. In the context of safety critical system, it refers to undesirable event. Like I will repeat again, these threats are intended acts, sabotage, okay, and deliberate attempts to harm a particular entity or nation or asset. In the context of threat, three salient and important features are, because human resource or human factor is a very important part of physical protection system. So, being vigilant, like we have surveillance on safety side, we have be vigilant all across. For even a small deviation, we should be able to appropriately react, record, and then let it be taken as a sort of analysis, and then what are the guidance that could be generated for this, or the infrastructure that could be used, or no action to be taken. So, like this, but then it should be all recorded and demonstrated. No deviation can be left out, and so there should be a security culture to have being vigilant, not only vigilant, recording all the observations 24/7, and then each of these should get the treatment and then analysis. Having required proactive, and then not only vigilant, proactive provisions. Like often I can learn from other organizations if some events have happened, so why it should not be implemented in my plant? because I am having similar situation. Even if I am not having similar situation, whether that is possible here. Similarly, advanced technologies which have come. So, proactive action should be there. Proven technology is good, but understanding and analyzing the advanced technology and using them for our own protection. Having resilience against threat, adequate plant physical or cyber protection system should be there, so that threat and if threat occurs, then it should not have any consequences. That should be our topmost objective. But then what all required to build a threat or define a threat or to create definition of a threat for a given entity. The definition of DBT should include postulation of all possible scenario or sabotage or unauthorized entry. In controlled area, its legal and potential condition probability of likelihood and potential consequences. Unlike safety, where everything gets settled at regulatory level, in the security, there are some legal provisions. So, it has got an interface with the legal aspects also. So, those should also be complied, and it should be. So, though regulatory approval and all will be there, but then it should be mapped on legal requirements also to avoid any complications. The expected availability, effectiveness of physical protection measures, either based on data or expert opinion, should be evaluated for possible. If data is not available, as we talked earlier, then expert opinion, it's like we will be discussing later some in topic 4 or 5th, the Bayesian updating. I mean, I have my own data which is limited, but I can use some mathematical technique to combine the generic data available in the open domain with the plant specific data, and to have an estimate of it. And as the plant sees the operation period, we will know that how well our data was there, and then go on updating that database. Complexity of DBT comes from not only from external or outside threat, it gets aggravated because of inside threat also. So, these two also, insider and outside threat, and the pathways which are there for the threat, type of attacks and technologies, and of course that might include the remote operation of certain things. It could be laser, it could be remote arms, or and pathways could be land, airborne, water. So, all this should be explored to create a definition of design basis threat. The maximum credible threat scenario provides the governing consideration for the design and protection of the system, especially the physical protection system in the design basis threat. So, once we have seen the definition, then we have discussed what are the requirement of design basis threat. So, how to formulate the definition. So, okay, the plants which are operating will have a lot of data, security logs, provisions, incident reports, they can form part of it. And of course, all these things should be subjected to regulatory review, and major insight can be obtained from national, international level also, as we discussed. And compliance, like a peer review or compliance with the regulator should be available in terms of provisions of defense in depth, in terms of performance over a period of time also. DBT provides a starting point for assessment of resilience, and that is that in term vulnerability assessment. So, resilience, converse of it is vulnerability. So, this gets validated over a period of time, and if not, then we perform drills, periodic emergency drills, or testing and all, there it gets validated. Now, the first step in this is review of internal and external records of threats that are available. Even if it is not there, the threat is not there in my plant, as I mentioned, it can be taken from other plant also if it has happened somewhere. Then a complete threat assessment is carried out, and it is documented also. As you can see here, it is documented also. Then define credible DBT and postulate scenario. Now once we have defined this DBT and other events also, then internal peer review is required. Internal and peer review. Internal review is the exhaustive exercise, and then peer review is required because we want some third party to contribute to improvement of this particular exercise in terms of security improvement. Then regulatory review is required, and then compliance and recommendation. And once you have a compliance and recommendation, again this is a cycle which is periodically revisited and reviewed, and then we have defense in depth and security in design. So this I have a particular chart I have adopted from Atomic Energy IAEA design basis threat document, and I think quite a bit of work has been done that is very useful for this lecture. Then now suppose we are all sitting there and we have to take a definition. That means this is one of the easiest thing, that whatever design basis threats that are available in open domain for the similar plant, same plant, or for other plants, let us take down those definition and then see how we can define our own design basis threat. So one of the source is IAEA. Now I have visited IAEA website and I saw only one description. A DPT describes capability of potential insider or outsider adversaries who might attempt malicious acts, attack, sabotage that become, and then I have adopted become governing consideration for design of assets like physical protection system. There is one open source definition is USNRC. DBA is defined as postulated accident that a nuclear facility must be designed and built to withstand without loss to the system, structures and components to ensure public health and safety. When I came to this lecture, how in generic sense we can give a definition of design basis threat. So the definition was formulated like this: postulation of all the probable, credible threat scenarios, including DBT case arising due to insider and outsider against which a facility must be designed, operated, maintained and protected, maintained to protect public health, loss of property, degradation of environment. To me, when we are discussing different aspects, this definition is comprehensive. So with this definition, we go ahead, and then in design basis threat, like we have for safety system, frequency of initiating event that you might remember we have discussed. So here also the frequency of design basis threat has to be evaluated, and if we are not able to get the frequency, then we can use it from some other sources in open domain, some data similar to our threat, or we can use a conditional probability of 1, that is that means the event has occurred, and then analyze all the systems and see. I don't think there will be any big compromise in this. Only thing is the accident scenario will be looking on higher side if we take this probability, but it's a good starting point. And then whatever values are available from any other source, we can do a sensitivity analysis so that we are more complete in the sense of having a it's called the best effort that have been made to characterize the frequency of design basis threat. So the two options are there. The condition probability is one, we have discussed that. Now let us see how to go for evaluation. Let's say we have a very limited experience, site specific, and where in 25 years one event, whatever event it was, event has happened. So, the frequency in 25 years, one event, we will get a frequency of 0.04 per year. Okay. Now there are some corporate experiences, that is every domain has got some business represented by collectively at national level or international level, and they have their own database. So there was one database, just is for the example sake it has been given, 8 into 10 to the minus 3. So you can see here 0.04 here, and then here it was there. So we can use it as a Bayesian updating, we can use it, or let's go at present with this 0.04 only. Now we are given one more input, that one out of these are all assumption, hypothesis, no real data. It is just for the understanding of the concept. 1 out of 100 disgruntled employees can pose an internal threat. This assumption is there. Okay, and then the frequency of threat will be T. T is threat here. 0.01, that we got the employee having this threat potential, and then 0.04 per year we got from here. So we got a frequency of 4 into 10 to the minus 4. And I think it's a good job when limited data is available, and this has been adopted from EPRI report, this particular formulation, and it is quite and as the plant operates over a period of time, this particular statement will get consolidated, Or if you have 10 plants in the country, all experience put together and having how many events, these are the things they provide strategy for quantification. Now we have discussed threat, its definition, its relation to vulnerability, and formulation of this design basis threat, and so one simple example quantification we have done, and to evaluate the threat frequency.